This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 2 weeks. Thanks to our audience and the partners listed on our website for supporting the podcast.
Hi everybody, this is Arno Hase with another episode of Software Engineering Radio, and today I'm interviewing Dave Thomas of the Programmatic Programmers about software archaeology. Dave, would you like to start by saying some words about yourself?
Oh, I hate doing that, but I'll try. Sure. I'm Dave Thomas. I've been programming now since programming long enough that you probably need an archaeologist to find me. I started back in the 70s, I guess. In the last 5-6 years, I've been having a secondary career as a book publisher. Andy Hunt and myself kind of accidentally fell into being publishers. We published Pragmatic Programmer back in 1999 and really liked the experience. In that time, we were actually going through another book publisher, Addison Wesley. So when it came time to publish a trilogy of books on basic software practices, we thought we'd try it ourselves. And from there, we kind of just kept doing it. So we've now got something like 60 books in print and another 50 books under development. So I'm being kept pretty busy on the book side at the moment. Mm-hmm. But underneath it all, my passion is still software, and I still write as much code as I can, as often as I can.
Yeah, I can sympathize with that. It's the same with me. I came across the term software archaeology based on a workshop you did in the UPSLA 2001. And, well, since I like reading code myself, I was wondering if maybe you could tell our listeners about how you came up with this term and what is it about.
I have to first say, it probably wasn't me that came up with the term. I believe it was Ward Cunningham, but I'm not 100% sure. The workshop was a joint effort of Ward Cunningham, Brian Merrick, Andy Hunt, and myself. And it was more an attempt just to get a discussion going on what we thought was a much underappreciated aspect of software development. I mean, after all, everybody spends all their time working out how to write code. So we'll have all the tools, the support, the UML diagrams, everything else to help us write code. But very few people actually spend any time at all working out how best to read code. And that's a really big mistake, because when you think about it, I would guess that probably the average software developer spends maybe 20% of their time writing code and the rest of their time reading it. And yet the training is totally the other way around. So we wanted to start highlighting the fact that code reading is as important, if not more important a skill than code writing. And why do I say that people spend so much time reading code? When you think about it, most of the time you're either going back and looking at existing code and making changes to it. That may be code that you yourself wrote just 5 minutes ago, but you're still looking at existing code. Or maybe you're called in to fix a bug in a system and it's 50,000 lines of Java and you have to find the one line that has the bug in it. Or maybe you have to add a new feature to some application or integrate that application with something else. Whatever it is, you're sitting there reading code in order to do your job. And as I said, we don't think anybody is taught how to do that effectively. So we would love to try and find ways of helping people do that.
So how do you go about reading code?
Well, there is no single one way of doing it. To some extent, it depends on why you're trying to do it. What is your motivation for reading this code? There is a group of people that includes me who enjoy reading code just because code is good to read. If you can find some well-written code, it's an educational and it's a fun experience to sit there and look at it. You know, how does this person do this? Oh, that's a really cool technique. I like the way they've done that. You learn stuff about algorithms. You learn stuff about programming. You even learn stuff about how to lay code out nicely. And so that's one reason, sort of recreational code reading, if you like. But you know what? I think that's actually a very important aspect of it. If you think about any other creative profession, if maybe you're a writer or a painter, you certainly don't sit there and just write or just paint. If you're a writing student, you'll be reading other people's work. In fact, most of your work will be, going through and reading the great classics and reading what other people have done, seeing how other people have constructed books or whatever it is you're writing. If you're a painter, you'll spend time studying other painters. And yet, if you're a software developer, you never read anybody else's code. You spend your entire time writing your own, which is an incredibly arrogant approach to the profession. So I think this idea of recreational code reading or educational code reading is a vitally important one. And it's much overlooked. I would love to see courses in college, a lot of courses on college, which are on code reading and code appreciation. I would like to see a growing corpus of work, which is great code that people read. I mean, seriously, I don't see why not.
Yeah, I think I've seen something like code gems or something like that. Sounds a good approach. But most people that I know, most developers that I know, sort of go like, oh no, I don't like reading code because it's so difficult. There's no way I can actually get to grips with other people's code. So what's your advice? How should someone go about approaching code that they don't know yet?
Well, there's a couple of things I'd say. First of all, like anything worth doing, it repays practice. It's not easy reading code, as you said, and that's not an excuse for not doing it. The second thing is that there are many quick and easy ways of reading code. For example, the first thing to realize is that you don't necessarily have to understand all of the code that you're looking at in order to be able to get the information out that you want. And if, for example, you're looking at a very targeted bug fix, then the approach to reading the code will be very different to if you were, for example, to be looking to move the code to a different language or a different platform or integrate it into your application in some way. So there are different approaches to take depending on what you're trying to do. The first thing you have to do when you're reading code, and this is going to sound very stupid, but is to make sure you've actually got the code. I have wasted so many days, so many weeks probably in my life, tracking down bugs in the wrong version of a piece of code. Or downloading what I thought was, the XYZ package, only to discover I got the wrong one, and it was just, And it takes a lot of time. If you're not familiar with the code base, it takes time for that realization to come in. So the first thing you have to do is to make sure you have the right code. Second thing to do is to make sure you have all of it. Quite often, you'll find that people are bundling their code up in weird kind of ways. One of the things you have to be very careful you have is you have all the code, all the libraries, and then all the tests and all the documentation. Now, if you have tests, you're lucky because the majority of code does not have tests. But if you can find it, you want to make sure you have everything you can get. The next thing you want to do is to put that into a version control system. Now, the code may already be in some kind of version control system. Depending on that system, you might want to put it into your own just temporarily. So maybe just copy it across and stick it into a local Git repository or whatever it might be, because you're going to be messing with that code. And the last thing you want to do is to make irreversible changes. So stick it into,
So sort of an interactive approach to reading, sort of reading and modifying the code as a means to read the code.
Eventually we'll get there. But as a very first step, in a way, this is kind of like laying out the ground. If you look at archaeologists, coming to a site, the first thing they do, they won't start digging. What they'll start doing is preparing the site. So they'll put up some kind of grid, they'll set up reference marks, etc., etc. This is what we're doing at this point. We're giving ourselves an environment in which we can have a bit more control as we're reading the code. Yeah, and I'm making it sound terribly formal. I mean, really, it's not a big deal. And just like doing a git init in a repository in a directory takes like 1/10 of a second. But just doing that is a really important step, because it means we then have a safety net in place, and we don't have to worry about messing things up as we go forward. So we have our code in front of us. So then the next question we got to ask is, okay, what is it we're trying to do? Now, maybe what we're trying to do is to find the cause of a bug. And if you're trying to find a bug, then maybe the bug is an exception gets thrown or an error message is output in certain circumstances. In those cases, your friend is a source scanning tool, something like grep or something like ACK, or if you're in an IDE, they typically have search the files in the project for a particular string, and just try and localize where that problem is coming from. And then from there, we can read backwards out to the source code. The one thing I'd say here is that there are two distinct kinds of software archaeology. And by looking at bug fixing, I'm kind of like mixing the two up. So what I'd like to do is step back a bit and, first of all, just look at the two different schools that you have here. The first one is pure reading. The first one is just the ability to scan through the source and see what's there. And the nice thing about that type of reading is you don't actually have to be able to compile or execute the code. The second kind of archaeology is more complicated because there you do actually have to create an environment in which the code runs. So if you're fixing a bug, for example, you actually have to be able to reproduce the bug, create a test for it, and then fix the code. And that's a whole extra level of complication. But let's start just looking at static source analysis and what you can do about that. What I like to do when I'm looking at a body of code like that is I will bring the entire code base up in, actually typically I don't use an IDE, typically I'll just use an editor like TextMate on the Mac, but I'll bring all of the code up and I will shrink the font size down fairly small and just quickly scan through it. Ward Cunningham in the archaeology workshop actually talked about a trick he had where he would load all his source code into Microsoft Word and then set the point size down to 2 points. And what happens is actually it's very interesting. If you do that, you lose the ability to read the code, obviously. But what you'll be able to see is the structure of the code. And you actually have a whole bunch revealed by that. You can see from the indentation, for example, how long things are. You can look for repetitive patterns. You'd be amazed how easy it is to spot duplicated code if you shrink the code down. And if you scan through that just a few times back and forth, you somehow build up some kind of subconscious map of what's going on. And that will help a lot when it comes to actually finding stuff later on. As I say, I don't use Word for that. I use TextMate, but I take the same kind of approach. I'll shrink the font down and then I'll scroll very quickly through it. I won't try and read it. I'll just scroll and watch the code go by.
Do you mean you do that on a file-by-file basis, or do you concatenate all the files for that?
I will do that on a file-by-file basis typically. And I don't necessarily have to dig into every single file. Typically you'll find there'll be kind of top-level files and then there'll be library and support files. And most definitely I'll go to the top-level files. I'll also try and find the files that contain application-level logic, the key core logic of the application, and look through that. And again, what I'm looking for is the structuring of the code. Just step back a bit. There's a really interesting... when we use the word software archaeology, we're actually misusing it greatly. Because when people talk about software archaeology, they're talking about the exploration. They're talking about the dig. They're talking about coming back with artifacts. But if you actually read what archaeology, real, out in the field archaeology is, it's not really to do with the artifacts. Archaeology, Indiana Jones notwithstanding, is actually about understanding the culture and the situation in which those artifacts were used. So archaeology is using the analysis of those artifacts and the environment in which they were placed in order to understand the culture that created them. And one of the things that you can do by quickly reading through the code is to start to get a feel for the team that produced that code. What kind of structure were they using? What kind of methodology were they using? You can probably maybe tell what kind of IDE they were using. Were they writing tests or not? Were they under some kind of coding guidelines that restricted the length of their methods? What kind of modularization philosophy did they have? All these kind of things you can tell very quickly by just scanning through the code. And I find it really useful to try and get into the head of the person who wrote code that I'm trying to read. Because then, when I have to try and answer a question, I can say, what would Fred do? And then by answering that question, I can typically find what I'm looking for in the code. So code reading is not really just about code reading. There's a little bit of psychology in there too. So I will scan through the code quickly, just trying to work out the structure of it, trying to work out the overall philosophy of how it would work. And then what I do next really depends on what I'm trying to accomplish. If I'm reading code for educational purposes, then during my quick scan, I will likely have seen kind of interesting features, things that I want to go back and examine a bit more. and then I'll scroll back up, or I'll go back and find those features, and I'll dig in. And along the way, I'll be leaving little breadcrumbs to help me. And that's why it's really nice to stick things into a source control system, because the kind of breadcrumbs I like to leave are just comments in the code. And so as I go through it, I'll make notes in the code using a comment. So I'll put a comment marker and then maybe say my initials and a colon so I can find it again quickly. And just make those comments to sort of annotate what I'm discovering. And I'll be reading through the code and, sort of looking for stuff that's interesting, looking for cool new techniques, cool new features, and annotating them as I go. If instead I'm looking for maybe an API so I can extend this code, then obviously I'll focus in on that section. But typically that section on its own is not going to be localized. I'm going to be looking at things like maybe the parameters have certain types, so I'll have to go and find out what those types mean, what the constraints are on those types, the invariants, and work backwards from there. Mm-hmm. If I'm finding a bug, then that's typically not going to be enough, and I'm going to have to go into a dynamic analysis rather than a static analysis. One thing I've learned over the years is that documentation is probably the least helpful thing.
Why is that?
Use. Because the second someone has written documentation, it's out of date. Even if it's something inline like JavaDoc, it still tends to fall behind. In the heat of battle, people update code, they forget to update the comments. If it's separate documentation, if it's some PDF document or some requirements document, then it's going to give you an overview. It's going to give you an idea of what the thing is supposed to do. But in terms of the details, I wouldn't rely on it at all. And that's kind of maybe a cynical view, but it's one that's been borne out by bitter experience. So one thing I am finding very useful is back when we held the workshop, which was 8 years ago, testing was something that was pretty uncommon, and it would be very rare to find a body of code that actually had unit tests in it. Nowadays, that's not the case, and more and more teams are using at least unit testing as a tool to help them get code better designed. And tests, unlike documentation, tend not to lie. I mean, assuming the tests actually pass, then they do tell you something about the code. And so if I can find unit tests, and if I believe those unit tests are good, then I will spend a fair amount of time looking at those as well. Because the unit tests show me how an API is supposed to be used. The API itself says what it can do, but the unit tests really reveal more about the character of the API and how the developers intended that API to work. And quite often they'll answer questions that aren't obvious from the code itself. So if you like, the unit tests give you an orthogonal view into the code base. It's a view that's kind of shifted through 90 degrees. You can attack it from a different direction. So if you can find tests, they're very, very valuable. So, and when we get on to talking about the dynamic archaeology, then we'll have a whole new use for tests a bit later on.
Okay, so are you saying code is better off without comments?
I'm saying that code is better off without incorrect comments, yes. And I'm saying that the majority of comments are obsolete in code. So that code, yes, is better off without comments. In general, I think that the most successful commenting scheme for code is a sparse one. I think people who write little novels at the top of each one of their methods are unlikely to come back and correct them. I think they're spending too much time duplicating information. I mean, why write a comment that says add 1 to the number of transactions and then write transactions equals transactions plus 1? It just doesn't make any sense. So I think, it may feel good at the time. There may be some kind of big virtuous shine that you get because you wrote documentation, and everybody knows that writing documentation, although painful and boring, is good for you. It doesn't really help that much.
Yeah, I think the main reason for that is organizational culture, organizational guidelines, that kind of thing. Because otherwise, I don't think it would happen as much.
I think there's a lot of that. I think there are also a lot of developers who, frankly, are nervous about writing code. I think code is the thing that reveals whether or not something has been done correctly, whether something works. And if you can put off the evil moment, then it's a good thing. And there's nothing better to put off the good moment than writing 3 or 4 pages of comments. So I think that happens as well. But for whatever the reason, I think that if I see code that has a lot of comments, then I tend to ignore them simply because I don't find them very useful. What I appreciate as a code reader is reading about the why. I'm not that interested in the how because the code shows me the how. And I'm not interested particularly in a list of parameter names and types in the comments because that's what the code shows me. But what I really am interested in is why did they do it this way, not that way? And those are the kind of decisions that help you get inside the head of the people writing the code. So if you are writing comments, don't duplicate what's in the code. That's totally pointless. And it will guarantee to get out of date as you change the code. Duplicate the higher level stuff, the abstract things. Say, why we took this approach, why this parameter is done this way, not that way. And keep it up at that level. The other thing that's really useful when I'm reading comments is navigational comments. Particularly if, for example, this algorithm comes off, this book or this website, or go see this external configuration file to see how this works, or whatever it might be. Things that help me find my way around are incredibly useful.
Yeah, that makes sense. You mentioned some time ago that you sometimes like to go for the core files, core code, the application scope logic. How do you find that? I mean, let's say you download a huge project or have a huge project of a couple 100,000 lines. How do you actually find the key parts?
Good question. And again, it depends on the program and the programmer. Sometimes.
So you sort of start skimming the code to get an understanding of the culture or get into the head of the program, and that helps you as a first step?
Well, there are a couple of things you can look for. First of all, you can normally find the helper files, the libraries, by looking for self-contained classes, self-contained modules that just do that are basically just a class that sits on a file. They are obviously instantiated somewhere else, and they're controlled from somewhere else. So those are clearly not the top level. The top level is going to be the thing that does the instantiating. It's going to be the thing that goes and finds the main business objects, loads them up, and does whatever it has to do.
Well, in times of dependency injection, it's not quite as simple as that, is it?
That is true. That is very true. And actually, that's one of the reasons in general, I'm not very happy with DI style of development, because I think it actually obscures the code quite a lot when it comes to reading it. I know a lot of people say, oh, it decouples, etc., etc. But what it really does is it gives you another dimension that you actually have to read in order to be able to understand the code. So that's, maybe a contrary opinion there, but it's kind of true. One of the things I look for to find the main file, again, it depends on the programmer, is quite often there'll be a directory structure or a module structure that makes it obvious. So the main files will be somewhere at a top level. Quite often, just because people are lazy, the main file will be the biggest one. It's kind of sad to say, but it just happens to be the way it falls out. So if you can find one big honking file, quite often that contains like a 400-line method, then that's probably the controlling thing that you're looking for. And obviously you can trace it through by looking at the entry point, the main or whatever it might be, and following it through there. The other trick that I like to use is I will find the name of, or I'll think of a name that I think represents a key concept in the code. And then I'll grep the source files for it. And I'll just basically do a grep -n to try and find who actually has the most occurrences of those names. And by doing
sort
that,
of like using your domain knowledge to get a grip on the structure.
Yeah, and it may not even be domain knowledge. I mean, if I'm dealing with, I don't know, let's think of an example, an application that does shipping, then it could well be I'll just search for postage or ship or package or something like that. I mean, maybe that is domain knowledge, I guess, but it's kind of common sense as well. But simply looking for the high-level concepts will typically lead you into that main area. And then once you're there, it's really just a question of, again, focusing. Why are you there? What are you doing there? And then, following the various tendrils out. Just in passing, I would say that if you are doing serious code archaeology, you owe it to yourself to learn the command line, because you cannot do it as effectively inside an IDE. You can do a lot of stuff in an IDE, and certainly IDEs are great for doing things like reverse engineering UML diagrams, if that happens to be your bent. But to do decent searching and powerful searching, you really do need to learn the command line. You need to learn tools like grep or ACK, and you need to learn pipelines, because if you have a lot of source code, then grep is going to return a lot of values, and you're going to want to be able to filter those results. So you want to be able to use grep, pipe the output through maybe another grep or a word count or something else, just to be able to get a sense of what's going on. A very, very common pattern for me is I will grep for something and see that I get maybe 500 lines come out. But most of those lines will contain stuff that I know is not relevant to what I'm looking for. So I'll pipe the output through another grep, either looking for some specific positive string, or quite often using grep -v, which means ignore lines that match this pattern. So I'll say, find every line that contains this, but not this. And that's a very powerful technique to be able to isolate things very quickly in a bunch of source code. And as far as I know, that's a pretty difficult thing to do in IDEs. So, as I say, I recommend getting comfortable with your tools.
To what degree would you say that patterns, architectural patterns, are helpful for getting an understanding of the overall structure of applications in practice?
Oh dear, you've just pushed a hot button. I think that if you have a team that has got the pattern religion, then clearly that is a useful technique to be able to understand the decisions they've made when they're structuring their code. Andy and I always used to joke that you could always spot a team that had bought a copy of design patterns because they couldn't write "Hello World" without 3 decorators, a visitor, and it's serious. It's like, I have to use a pattern. Every single class I write, I have to be able to say in the comment box, implements the XXX pattern, whatever that might be. And it just went totally over the top. And a lot of people misunderstood what patterns were. Everybody thought patterns were kind of like software Lego. And, I'll construct my software by building it out of a whole group of patterns. And that totally misses the point. Patterns are not a construction device. Patterns are a way of dealing with common issues when you're writing code. There are idioms. They're not designs. But yeah, people forget that, and so we'll end up with code like that. If that's the case, if you're seeing code where class names have the names of patterns embedded in them, then that's clearly a hint that the following structure obeys something close to the pattern. However, again, my experience has been that many teams will use the name of a pattern but not really understand what they're doing. And so, although you may find a class called, stock visitor, it may well not be anything close to a true visitor pattern. So, you have to treat that very, very carefully if you see that in code.
Yeah. I see what you mean, but I was thinking at the larger level, like understanding layers and the understanding the team had of layers in large application. Or let's say you have some kind of, model view controller based system with several levels of models, whatever. Do you find that these kind of structures are helpful to have in the back of your mind, or is what you just said valid or true as well at the larger level?
I think it's definitely helpful to have in your mind because it gives you hints as to where things may be. But again, I think the devil is in the details. And so if you get it into your head that this is a good MVC design and therefore there is no business logic in the view, I think you'll be sadly disappointed with 90% of the MVC implementations out there.
I see what you mean.
And so if you're sitting there and you have this preconceived idea that this is some kind of, ideal MVC, and then you're looking for, some particular piece of logic or looking for a validation or whatever it might be, you can fool yourself into not finding it. So I try to keep an open mind. Now, having said that, that's one of the reasons that the initial quick read-through really helps, because, I'm being a bit cynical here. There are teams that do it right, or there are teams that obviously get some of it and you can understand what parts they've gotten. So if you read through and discover, hey, they know what they're doing, and there is no business logic in the view or whatever it might be, then that does help, and you can work from there. So I think patterns are a hint. They give you something to look at as you're reading through, and then you can make your own mind up as to whether in fact they actually have been obeyed and whether they're useful or whether they're not. And you're right, there's also a larger structuring pattern that you have to understand. How does the whole program hang together? It's actually surprising how much you can read without actually understanding that. It's possible to actually get a whole bunch out of a program without understanding its sort of macro structure. But obviously, if you're going to do any work on it, then you have to understand that as well. And if you're lucky, the breakdown of the source will help you do that. They'll modularize such stuff in such a way that you can work that one out. And again, maybe the naming will help you there. But sometimes you just have to fall back on executing it and seeing what happens.
Which gets us, or it sounds like it gets us to the dynamic archaeology that you're talking about.
Right. Because everything we've done so far has been pure passive reading of the source. We'll be maybe adding annotations as we go through, but we haven't been trying to execute that source. So the next thing that we'd want you to do is to run it. And this is where life gets interesting, depending on where the source comes from. Because very few pieces of source exist in isolation. They need an environment in which they can run. They'll need libraries, they'll need utilities, they'll need a certain database configuration, they'll actually need a connection to that database, they'll need to be put into some kind of container possibly, whatever it might be. And so you're relying very heavily on the people who wrote that code giving you strong hints at the minimum of how to put it all together and how to run it. In the ideal world, you'll have some kind of executable script, whether it's a makefile or ant task or maven or rake or whatever it might be. You'll have something that actually helps the application knit itself together and start running. If you're doing archaeology on open source projects, for example, then if it's a C-style project, you'll probably find a configure.in script, which means that they've been considerate enough to use autoconf. You'll find a makefile to build it, and that will give you some very strong hints. But you will probably find yourself in dependency hell, for the first day or two as you try and get this thing just to compile and then finally to load. That in itself is not necessarily a bad thing, because it also gives you an idea of what this program is doing. If you suddenly find it using an XSLT library, then you'll know it's doing XSLT somewhere, probably. And that's actually kind of important information to gather. The other thing that's the most frustrating at this stage is that, particularly this is older code, and by old I mean maybe 2+ years. Well, it's seriously, though, the way the world is changing. They may well rely on old versions of libraries that they haven't documented the particular version they're using. So you'll see they use some, they have a requirement for whatever it might be. So you download the latest version of it, and the thing just doesn't work, or there's missing entry points or whatever it might be. And so you find yourself then going back and trying to guess versions of libraries that work with this particular software. So there's a lot of detective work that takes place in this section, and it's very frustrating detective work. The very worst, the days where you just want to throw your computer through the window are the days where you say, oh, look, it needs this library. So you download that library, and that library itself has 15 other dependencies, and you download those, and you get the whole thing to compile, and then discover you're using the wrong version of it, and you have to throw it all away and start again. in those environments, if you find yourself in a serious environment like that, one thing that I've tried doing has been fairly successful for me is I'll actually set up a virtual machine. I will run inside a sandboxed machine. So I'll use something like VirtualBox and load up an operating system inside my own operating system. And that means that I can download libraries, and then if I get it wrong, I just blow the whole thing away and start again. This applies particularly, this isn't so much for Java, but for the C-style libraries that knit themselves in globally into your system. They'll load themselves into user local or wherever it might be. Those things are a real pain to get rid of. And being able to just blow the whole thing away and start again actually saves a lot of time. The other hint I've got when you're in that stage is if the people who wrote the software did not provide a script to set up everything you need, now's your time to do it. Because as you go forward, you will find yourself having to rerun those installations. If you get something wrong, you may have to blow it off and start again. And having a script that does what you want to do will save you a whole bunch of time. And the next person that comes along to look at this code will build a statue to you because you've made their life so much easier.
Yeah.
So it makes your life easier, it makes their life easier. And that script can be nothing more than issuing some curl commands to download software and then whatever the build instruction is for that software. It doesn't have to be elegant, it doesn't have to be neat, it just has to get something done. So that's step one to get the thing running. Then you've got yourself an executable. You actually have to do something with it, and that also is often a challenge because maybe the application needs a database, and so you'll have to find some way of working out what the schema is, creating that database, and then working out how to connect the application to that database. Maybe it's a web application; it needs to go into some container somehow. Again, hopefully they'll have automated that, but you just have to make sure. So at some point in the process, you've actually got yourself a running application. So then the next thing is, well, what do you do with it? This actually is where the documentation can come in useful, because documentation at that kind of level, at maybe the user level, will give you a better idea of how the software is supposed to work. It probably won't be exactly accurate, but it will at least tell you that, if you want to do this kind of thing, then this is the menu you want to be going to, or this is the button you want to be pushing, or whatever it might be. So, you could use documentation at that level. So once you've got yourself a running program, this is where the fun starts, because now you can start doing dynamic archaeology. And there are a whole host of ways of doing that. Some people like to bring the application up in their IDEs or whatever they might use and use the debugger to set breakpoints, to single step through it, to watch the flow of execution. I think that's really useful, but it's also quite hard to get right. Setting breakpoints is one of those things where if you get it right, it's great. If you get it wrong, it's incredibly frustrating because you set the breakpoint and then you go through the whole setup manually and get the thing to work, and then suddenly the breakpoint doesn't fire because it's going through the else branch, not the if branch or whatever else. So that can be really kind of tricky. So I tend not to use breakpoints as much as I will insert code that will raise an exception. So if I want to see what's going on, I will stick whatever the throw or raise or whatever the statement is in a particular language in at a particular point, and that gives me two things. First of all, it means that whenever I go through there, it's going to blow up, and that means I get to see something happening, and I get a stack trace. And if I'm lucky, I get a stack trace that also shows me the values of parameters and everything else, so I can see where I came from, and quite often that information is really important. The other nice thing about those is you can just leave them in the code and then they will blow up, at some point in the future as well. So if there was some case that you weren't too sure about, why is it that, they had this code in here in the first place, stick a fail in and then just, over the course of playing with the code, at some point that exception may get triggered. And if it does, then you'll be able to see the state and why it got there. So that's kind of useful. I know a lot of people use kind of println debugging. They'll stick, puts or println or whatever the equivalent is in your language into the code. That can be useful, but it can also get very verbose very quickly. So I think that's something to be used very locally to look at particular problems. In general, I find that less useful than raising exceptions. Things that are also very useful are execution profilers, because not only can you find out the coverage of the code and see where the code is being used, but you can also see where the code's not being used. And again, that can be interesting and pertinent information when you're trying to work out how to change this program. And last but by no means least, in fact, last but probably first, remember we were talking about tests earlier on. If you are in a situation where your program does actually come with tests, then you should probably first go out and sacrifice some small animal just in gratitude. But you should then go and try and run them and see if they actually execute. And maybe one time in 100 they will.
Oh, really? Is that rare?
Well, I mean, as you know, code rots. If you leave code unattended for too long, bits fall off it and things, and it just stops working. Mm-hmm. And one of the things that reveals that is tests. I don't know why, but you can get some code, and apparently all the tests must have passed at some point because they shipped it. And then 2 years later, when you try and run it, for some reason, you get 17 failures. It's just one of those things. But even so, the tests, if you can get the tests to the point where they even try and run, then you're in a really good position. Because you can then dig in and actually play with the code from the test point of view. If you don't have tests, then here's a strong suggestion. Think about adding them. Now, I'm not saying here that you look at your 100,000 lines of code and say, I know what I'll do today. I'm going to write 150,000 lines of tests. No, that's obviously not the way you go. But if you are investigating an area, and here I'm not just talking about bug fixes, I'm also talking about the educational kind of testing. If you're investigating an area, then you'll form hypotheses in your head. Okay, I believe this method does this, or I believe this parameter means that. Well, there is no better way of testing that hypothesis than writing a test. So write an exploratory test that just tests that one hypothesis. And if you're lucky, and if the code is halfway decently written, you'll be able to execute that test and say, oh yeah, I was right, or oh no, that was not what it did in the first place. And if you leave those tests lying around, then the next person to come to that code will have a slightly better position than you had when it comes to understanding it. So I love writing little exploratory tests. Now, sometimes those tests just aren't possible because sometimes the effort of setting up the environment in order to be able to run this one piece of code is just too much. And in those cases, I'll fall back on putting exception in the method and looking at the parameters and this kind of thing. But if I can get away with writing tests, I love that as a technique for both understanding and also documenting what a chunk of code does.
What would you say is a particularly well-readable programming language? I mean, there's all kinds of obfuscated whatever contests. So the opposite of that, what language makes reading particularly easy in your experience?
I think that every language is potentially readable. I think the first thing is that, to some extent, fluency and readability are in the reader as much as the writer. In order to be able to understand the language, you actually have to know that language in the same way you do with a human language. There may be the world's prettiest piece of Serbo-Croatian poetry that wouldn't be in any way appealing to me because I don't understand it. And the same with code. People who say, oh, Perl is ugly, are people that have looked at it superficially and haven't actually taken the time to learn Perl. There are things that do make Perl hard to read, but it's a language, and you have to learn what all the various symbols mean, what all the various conventions mean, what all the various idioms mean, before you can hope to make that judgment that Perl is ugly or Perl is nice. There are some very elegant pieces of Perl code, and there are some very ugly pieces of Perl code. There's some very elegant pieces of Java. There are elegant pieces of COBOL. It's really, I think elegance is language agnostic. I think a lot of people get very religious about languages and say, oh, this language is a lot easier to read than this. It's not. It's just you have to learn the language, you have to understand the language before a language makes sense.
I think this sort of goes back to what you said about getting into the head of people to not only know the language, but also to try to understand their particular style, their particular culture of using the language, their idioms.
Absolutely. Idiom is a really good word, and that's a really key word, because people will use idioms. And the more you expose yourself to those idioms, the better the programmer you'll be. Because if you keep those in your back of your head, then the next time you have that kind of problem to solve, you'll be able to use that idiom. So yeah, I strongly believe that getting into the head of the people and understanding the style in which they're writing is crucially important.
So let's say some of our listeners find this idea fascinating and want to get started with reading foreign code. What would be your practical advice for the people who've not done a lot of code reading to get started, sort of at a concrete level? What should they do?
Excellent question. Excellent question. I think the first thing is not to be too ambitious. You are doing something which is very, very worthwhile, but you're also doing something which is actually quite difficult. So don't set yourself the job of understanding the Linux kernel as your first code reading exercise. I think, first of all, stick to a language you know well. So if you're a Java programmer, then say, okay, I will learn some Java code. If I'm a C#, I'll do C#. Then I would suggest just choose an open source project that has some vague interest to you, and download the source. Aim for something which is maybe 5 to 20,000 lines of code, something in that kind of area. And then, knowing that piece of software, give yourself just a couple of simple questions to ask. And let's try to think of an example. Say, for example, you're a Java programmer. Then maybe you download a library that creates PDFs, say something like iText. And so you've got this lump of code in front of you, and you're trying to understand how it works. So ask yourself, okay, can it produce compressed PDFs? And if so, what mechanism does it use? Now, that's actually a relatively simple question to answer in kind of code archaeology sense, because you're going to be looking for a couple of potential key phrases in the source that will help you. I mean, a simple grep for compress may well just answer the question, or you can choose, some other keywords that would help you find what compression it was using. Or ask yourself, okay, does it support Unicode? And if so, how? And look for those kind of answers, because they're practical problems that you may well bump into. If I download this package and I want to know what is my support for Unicode, well, I could go read the documentation, or I could just look at the source and say, okay, what does it do with characters that aren't built into the printer? How does it handle that? This kind of thing. So download some source code and answer some very basic questions. The next time you bump into something surprising when you're using some external software, don't just shrug it off, but set yourself the challenge of finding out why. And go and download the source code and actually work out what's going on. And you may say, that's a big, big waste of time. It's not. It's study that will repay itself. Chad Fowler and I do a studio on advanced Ruby. And the second topic we cover on the first day is reading the source code of the Ruby interpreter. And we do that because, Ruby obviously is a high-level language. It's got its own syntax and everything else. But underneath it all, it's written in a mixture of Ruby and C. And the guts of it, the core of the Ruby interpreter, at least Matz's Ruby interpreter, is, I don't know what it is, maybe 10, 15,000 lines of C code. And that is C code that is very well structured, very well put together. The naming is a bit weird, but it's got a very consistent structure. And it repays study because it answers questions that are not documented anywhere. So you can go into the source code and find out, is there a difference between this method or that method? Or if I got this weird exception, what does it mean? And so we show students how they understand, or how to understand both the lexical side of Ruby and also the interpreter side of Ruby in the source code. And people go, wow, I never knew all that information was just sitting there, and it's there for the taking. So that's an interesting thing to try and do. I mean, if you're a Python programmer, do the same thing and just dig around and see how it works. Because you kind of owe it to yourself. In the Pragmatic Programmer, we have a section on beware of evil wizards. There's a whole group of people. Well, no, I mean, if you think about it, there's a lot of people who use IDEs, and the IDEs have some kind of code generation built in. I mean, it may well be that you can click a button to create a project. And, I mean, the last time we looked, and this was a long time ago, the last time we looked, if you're using, I think it was Visual Studio, to create an empty project, it creates over 1,000 lines of source code. I bet you probably at least 50% of the people that do that have no idea what that 1,000 lines of source code do.
Mm-hmm.
And so they're sitting there developing their applications on a foundation that they themselves don't understand. And if something went wrong or something unexpected happens, they're totally at a loss because they have no knowledge of how their own application works.
Mm-hmm. It happened to me today. I did a code review with a colleague and asked him why he did things in this particular way. And he said, well, the IDE did that for me.
Right.
That was sufficient reason for him, yeah.
Absolutely right. And if that happens to blow up, and if that happens to blow up in production, and you're faced with that, you're lost, absolutely lost. So that's another form of code archaeology that I would strongly recommend that people do, is to get into the environment they're using. And so if you're a Perl or a Python or a PHP or a Ruby programmer, understand the interpreter and understand the libraries. I'm not saying you have to be able to write anything. You don't have to be turn yourself into a C programmer or an assembler programmer, but whatever it might be. But at least understand the structure. I mean, you can understand C. If you can write any block-structured language, you can understand C. And that's all you need to be able to do. You just need to be able to read through it and see what's going on. It will really, really help. So again, that's kind of like maybe part 2 of the road to code reading nirvana is to understand your environments and use code reading to understand what's going on in the applications you're writing. And then really part 3, I guess, is as you start to get proficient at it, you'll find yourself being able to take on things that you previously wouldn't be able to do. And that will be larger and larger bodies of code. If you do that, you might want to think about kind of remembering them somewhere. And that's where it's nice to have a version control repository. Remember, we talked about having a repository lying around locally so that if you modify the code, you can see what modifications you've made and keep track of them. Well, it's also useful to have that repository because if you find little gems, they'll be in your repository still. I mean, I keep a little repository down on my machine here. It used to be Subversion, now it's Git, of stuff I found. And it's not runnable code. It's just little chunks of code, like a little scrapbook of useful little stuff, useful little algorithms. And, maybe even just like, that's a really cool way of laying out that piece of code. And I'll just keep it lying around. And maybe once every 6 months or so, I'll just open the whole thing up and just quickly read through it, just to remind myself what's in there. And again, that's kind of like, in the same way that people will go through great works of literature and, highlight sections that are significant. They'll write essays on, just single sentences and what they mean. It's the same kind of thing. We're doing analysis and we're doing criticism on the content of the stuff we're reading. And I think that's really important.
Yeah, thank you very much for all these insights into reading source code. The time is almost up. Is there any last words, anything else you'd like to share with our listeners?
Well, one thing that I live in Texas here, as you can probably tell from my accent, and There are a lot of people get together here and do book clubs where they'll sit down and they'll meet up at a coffee shop or somewhere, and they'll assign themselves a book, and then every week they'll get together and discuss the next chapter or 2 chapters, whatever it might be, and what was the author intent, blah blah blah. At the same time, we have a lot of groups that get together, and there'll be like a Java users group, and there'll be a Ruby user group. They get together and basically complain about the state of the job market, but in theory, they'll be talking about their programming language. What you might want to consider doing is combining the 2 ideas and having a group that gets together and talks about some code. So you could assign yourself code, and the group could look at it and give a specific task. So you'll say, I want you to look at this module or these modules, or analyze how this works, whatever it might be, and then get together and talk about what you discovered. It sounds kind of a little bit geeky. It sounds a little bit weird, but I think you'd be surprised at the kind of insights that different people have reading the same code. It's very easy to get locked into a particular way of thinking. If you allow other people's ideas to come in, then suddenly code becomes a whole lot richer. The other thing that you can do when you get together as a group is you can kind of hone your critical ideas, because I don't think you necessarily want to look at just great works of code. If nothing else, they're kind of hard to find. But look at any piece of code and say, I like this, I love the way he did this, I love the structuring that she used over here, but this was horrible. And, did you notice that they did this, this, and this when they could have done it this way instead, and everything else? And those are the kind of discussions that, in my experience, are the most interesting. Because, you sit there and you say, well, clearly this was a bad idea, and then someone says, well, actually, no, it was good because of this, and then the whole group gets going talking about that particular decision. It's actually a kind of deep way of learning about coding. So I guess I'm going to leave you with anything. It's 2 things. One is code reading is probably as important, if not more important, than code writing. And secondly, doing it in a group is a lot more fun than doing it on your own.
Yes. Well, thank you very much for taking the time to share all these things.
Absolutely my pleasure.
And thanks everybody for listening to Software Engineering Radio. Bye!
Thanks for listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example, by clicking on the Dig Reddit Delicious links and the /dot button. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the Podsive Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.